All right, folks, welcome back. We are with section 7.3, Similarity and Transformations. Our essential question today asks, how can I determine if two figures are similar or not? So the thing that we are going to discuss today is that idea of similar. So let's go ahead and define it. Two figures are similar if the two figures can have the exact same size, and probably should throw in here shape, after a series of transformations and or dilations. So as the first two lessons went on this week, we talked about congruent figures where they were the exact same size. They just were not, the two figures were not in the same position, so we had to move them around so they could overlap. Now, with the idea of them being similar, I'm changing them to the same size. I'm able to do that using dilations, and then I can use the other series of transformations to get them to overlap. That doesn't always occur for everything, but some examples it will occur. All right, so let's start here with example one. I'm just going to give you two triangles. All right, so let's make this one A, B, C, and let's make this one D, E, F. All right, and the question is that we're going to ask, are they similar? So I need a little bit more information. I can't just say, well, I can shrink this down here, I can enlarge this one here without having some numbers. So let's say that the height of this triangle is 10 and the base length is 6. The height of this one's 5 and the base length is 3. All right. Can I shrink this one down and then slide it over to overlap it? All right. Can I dilate it? That's what we're looking to see. All right. So what I noticed is that if I dilate this by 1/2, that gets me to 5. If I dilate this by 1/2, that gets me to 3. I don't have to know that third side for a triangle. I just need to check 2 out of the 3 sides. All right. So since I am able to shrink this by 1/2, multiply by 1/2, and this by 1/2, and they would be the exact same numbers, yes, they are similar. It works. Yay. Example 2. Give you a funky little quadrilateral here. We'll call this quadrilateral A, B, C, D. And then I got this one over here. We'll call this one E, F, G, H. We're going to ask the same question here. Are these similar? Just because they're the same shape doesn't necessarily mean they are similar, though. All right, so I'll give you some numbers here. Say this AB is 3, AD is 5, DC is 5, and then let's say EF is 2, EH is 4, GH is 4. All right, before I forget, our movie quote during our lesson today that you need to include somewhere on your homework. The movie quote today is, I collect spores, molds, and fungus. So if you can write that down, that's great. Even if you look that up and find the movie that's from, even better. It's kind of a funny movie, one of my favorites. So now we're going to see if I can shrink this one down to get over here. Well, obviously, First thing I'd have to do is I'd have to reflect it over and flip it over so they'd be facing the same direction. And it doesn't really matter, I guess, if I'm going to go from here to here or here to here. That part doesn't mean anything. All right. The first one, we had to check 2 out of the 3 sides. This one is a 4-sided figure, so we need to check 3 out of the 4 sides, just to be sure. Okay, just to be sure. All right, so let's, what I'm going to compare is, I'm just going to kind of, if I could have, when I compared these numbers up here in the previous example, if I would have created fractions out of it, 10 over 5 and 6 over 3, that's the same exact fraction. They both simplify down to 2 over 1. So I'm going to do the same idea here. All right, I got AD to EH. So that's what I'm going to try to do. AD over EH. AD is 5 in its length. EH is 4. And if I wanted to, I could take that down to 1.25. Okay, so that's what that would be as a decimal. All right, so let's try a different one. Let's say, I don't know, let's go DC. And DC is in a similar spot as GH, or HG, however you want to look at it, don't matter. And this is 5 to 4 as well. So that's also 1.25. All right, but there's only 2 sides. We got to do 3 out of the 4, so we just got to go to the last set that we have numbers of. All right, so that would be AB over EF. AB is 3. EF is 2. 3 over 2 is 1.5. Since these 3 numbers are not the same, they are not similar. On the previous example, 10 over 5 is 2. 6 over 3 is 2. They're the same number. We're good to go. These ones are not the same number, so it does not work. So they're not similar, even though they look like the exact same shape. All right. Example 3. Give you this quadrilateral. Give you this quadrilateral. Let's say this is 8, this is 3, this is 4, and this is x. All right, so now these 2 ideas, these 2 are similar. I'm coming out and telling you they're similar. All right, I want to figure out what x is. Some of you may be able to figure that out in your brain, some of you may not. Either way I look at it though, the 8 and the 4 are in similar positions. The 3 and the x are in similar positions. We want them to be the same. What number does x have to be? All right, well, 4 is half of 8. So what is half of 3? 1.5. All right, we'll talk about more about this proportion stuff tomorrow in that lesson, but that's essentially what we're doing. Okay, I'm gonna have to figure out if information is similar or not, make sure I'm comparing everything correctly, and then utilize a little bit of problem solving skills to figure out something, some missing measurements when they're telling me that the 2 figures are similar. All right, that's all I have for today. We're gonna be in page 541 in our textbook, so make sure you're prepared for that. If you got any questions, you know where to find me. See ya.